Hello everyone. Uh, Today's our question is that a large disk made up of aluminium, a large disk made up of aluminium that is a non-magnetic material is kept horizontally. This is in this way. This is the aluminium disk that is kept horizontally and is free to rotate about its axis. This is the axis of this aluminium disk, and the disk is free to rotate about its axis. As shown in this figure, a strong magnet, this is the strong magnet that is held vertically at a point up above the disk away from its axis. On revolving the magnet, this magnet is being revolved in this direction about the axis of the disk. Now we have to tell that the disk will rotate in a direction opposite to the direction of motion. We have to tell whether the disk will rotate in a direction opposite to the direction of magnet's motion or in the same direction that of magnet's motion, whether it will not rotate and its temperature will remain unchanged, or it will rotate but its temperature will slowly rise. We have to choose any one option from this. Let's see how this question could be solved. Let us see this in next slide, that this is the aluminium disc, and here is the axis of the disc. Any magnet that is this way, that is, and here this is facing the north downward and south upward. This is the magnet. That magnet is being rotated about its axis, about the axis of the disc. Now we have to calculate whether the disc will rotate in which direction, or the disc will rotate or not rotate. Now use the concept of this thing, that we all know that magnetic material or any magnet produces magnetic field lines, that will produce magnetic field lines, and the direction of magnetic field lines are away from the north pole, that are away from north pole, and towards the south pole, towards the south pole. Now from this diagram, magnetic field line will emerge out from this north pole. And let us consider a small area A element, A. Let's magnify this here, that this is the small area element A, and the magnetic field lines are crossing this surface. Magnetic field lines are crossing this particular area A. What will happen, that magnetic fields are going downward toward this area, that is going downward. That means the current in this direction will be this downward, and in this direction the current will be in here, the current will be in this direction, that is the clockwise direction. The current will flow in clockwise direction. Current will flow in clockwise direction in this particular area element. Then we all know that in the clockwise direction, let's consider this from this concept, that south pole, that in south we can, what will happen in south, that the current will flow in this way, that is the clockwise direction. For the extra knowledge, I am telling you that for the north we draw this in this way, that is, if the upper face is acting at north pole, then the current will be in anti-clockwise direction. This is the extra knowledge. Now in this question, what is happening, this is the way, and this is the area element A, and the magnetic field lines are crossing this area, and the current is flowing in clockwise direction. That means this is acting as the south pole, the upper face of the disk that we are considering the small area element, that is acting as a south pole. Now what will happen, as the magnet is rotated about the axis, magnet is rotated, then what will happen, the field lines crossing this particular area will decrease. As the magnet is rotated, the field lines across this particular area will decrease. That means the flux across that will be, magnetic field lines are decreasing, flux is magnetic field per unit area, that is a magnetic flux. That means if flux lines are decreasing, then what will happen, the magnetic field is changing magnetic field will produce what, the changing magnetic field will produce the induced EMF, and that is in such way that the induced EMF in such a way that will oppose the change in the change of flux, that will, the induced EMF will be such that that will oppose the change in the flux that is taking place. That's why what will happen, as this thing is in this way, if the magnet is moved in this direction, then what will happen, the magnetic field lines across this particular area will decrease. Then it will try to increase that things, it will oppose that change, opposing that change. That will what will happen, if this is moving in this direction, the disk will also move in this direction. This is the case, the disk will move in the same direction as the magnet is moved. Or in another sense, we can say that this is the north pole, this is acting at south pole, and what will happen, north attracts south, the opposite poles attract each other. That means if this magnet is moved in this direction, that will attract the south pole. That means the disk will start rotating with the magnet in the same direction as that of the rotation of the magnet. That means the correct option in this is the this will rotate in the same direction as that of the magnet's motion. That means option B is the correct option. Hope this answered your questions. Thank you.